Imagine standing on the ground, staring up at a clear blue sky, when suddenly the earth beneath your boots begins to violently tremble. A low, thunderous rumble rolls across the horizon, a sound so deep you feel it in your chest before your ears even register the noise. Seconds later, the horizon erupts into a solid wall of fire and pulverized dirt, a localized earthquake tearing the landscape to shreds. You look up, straining your eyes, but the perpetrators are invisible, hiding in the stratosphere over 30,000 feet above you. This is not the wrath of a deity, nor is it a natural disaster. This is the staggering, unadulterated, destructive power of the Boeing B-52 Stratofortress, a machine affectionately and respectfully known by its crews as the Big Ugly Fat Fella. For over 7 decades, this 8-engine Leviathan has served as the ultimate symbol of American air power, casting a massive swept-wing shadow over battlefields across the globe. Today, we are going to dissect the anatomy of this flying fortress, tearing into the engineering, the strategic desperation that birthed it, and the sheer industrial muscle required to keep it in the sky. If you are a student of military history, a veteran, or simply someone who respects the cold, hard logic of overwhelming firepower, you have found your command post. Welcome to the channel. Hit that subscribe button, ring the notification bell to secure your perimeter, and drop your thoughts in the comments below as we analyze the defining weapon systems of the modern era. To truly understand the B-52, we cannot simply look at its massive bomb bays or its iconic silhouette. We have to rewind the clock to the late 1940s, a period of intense strategic paranoia and rapid technological evolution. The dust of the Second World War had barely settled, but the geopolitical landscape had already fractured into a bipolar standoff between the United States and the Soviet Union. In 1945, the United States possessed the ultimate trump card, the atomic bomb, and the means to deliver it, the Boeing B-29 Superfortress. But the B-29, despite its pressurized cabin and remote-controlled turrets, was a piston-engine relic in an era that was rapidly embracing jet propulsion. The Soviet Union was vast, spanning 11 time zones, and its interior was heavily defended. Striking targets deep inside Soviet territory from bases in North America or Allied nations required a bomber with unprecedented range and payload capacity. The immediate stopgap was the Convair B-36 Peacemaker, an absolute behemoth of an aircraft, featuring 6 Pratt & Whitney radial engines pushing and 4 General Electric turbojets pulling. The B-36 was an engineering marvel, but it was also a logistical nightmare. Crews joked that it had 6 turning, 4 burning, 2 smoking, and 2 choking. It was slow, cumbersome, and inherently vulnerable to the new generation of jet interceptors rolling off Soviet assembly lines, like the Mikoyan Gurevich MiG-15. The United States Air Force needed a pure jet bomber capable of carrying a massive nuclear payload at high subsonic speeds over intercontinental distances. Why would the military pour millions of dollars into a completely unproven jet bomber concept when piston engines were reliable and understood? The answer is simple: survival. In the nuclear age, speed and altitude were the only guarantees that your bomber force would survive long enough to drop its payload and deter a first strike. In October 1948, a team of Boeing engineers, led by Ed Wells, George Scherer, and Vaughn Blumenthal, arrived at Wright-Patterson Air Force Base in Dayton, Ohio, to present a turboprop bomber design to the Air Materiel Command. The Air Force brass took one look at the turboprop design and rejected it outright, telling the Boeing team they wanted a pure jet-powered aircraft. The Boeing engineers were given a single weekend to come up with a completely new design. Retreating to their rooms at the Van Cleve Hotel, they worked frantically, utilizing a balsa wood model they carved on the spot and drafting a 33-page proposal. By Monday morning, they presented the Air Force with the fundamental design of what would become the B-52. It was a masterpiece of aeronautical engineering, featuring a 35-degree swept wing and 8 jet engines paired in 4 underwing pods. This weekend in Dayton remains one of the most legendary development cycles in the history of the military-industrial complex. The leap from the drawing board to the runway required a mobilization of American industrial capacity that mirrored the efforts of the Second World War. Boeing utilized its massive facilities in Seattle, Washington, and later Wichita, Kansas, to churn out these aluminum leviathans. Let us look at the sheer scale of this machine. The B-52 features a wingspan of 185 feet and a length of 159 feet. The wings are so massive and flexible that they can flex up and down by as much as 32 feet at the tips during flight, a necessary design feature to absorb the intense turbulence found at high altitudes and during low-level penetration runs. To power this beast, Boeing initially selected the Pratt & Whitney J57 turbojet engine. Because early jet engines lacked the thrust of modern turbofans, Boeing had to strap 8 of them to the wings just to get the fully loaded bomber off the ground. A fully loaded B-52 can weigh up to 488,000 pounds on takeoff. To generate enough thrust on the runway, early models utilized a water injection system. By injecting demineralized water into the engine compressors, the air density was increased, providing a temporary boost in thrust. This resulted in the iconic apocalyptic trails of thick black smoke that characterized a B-52 takeoff during the Cold War. When analyzing the strategic context, we must compare the doctrine of the United States Strategic Air Command, or SAC, with the defensive posture of the Soviet Air Defense Forces, the PVO. Under the iron-fisted command of General Curtis LeMay, SAC was built around a singular, uncompromising philosophy: constant readiness and overwhelming nuclear retaliation. LeMay transformed SAC from a demobilized post-war remnant into the most lethal striking force on the planet. The B-52 was his ultimate weapon. The initial doctrine was high-altitude penetration. The B-52 would fly at 50,000 feet above the effective range of early Soviet anti-aircraft artillery and interceptors, drop its thermonuclear weapons, and return home. This was a direct evolution of the daylight precision bombing doctrine utilized by the 8th Air Force during the Second World War. But where a formation of B-17 flying fortresses over Schweinfurt in 1943 carried thousands of pounds of high explosives to destroy a ball-bearing plant, a single B-52 carried enough destructive power to erase an entire metropolitan area from the map. One aircraft now held the strategic weight of an entire World War II bomber armada. However, the technological pendulum always swings, and the Soviet Union was not sitting idle. The introduction of the S-75 Dvina surface-to-air missile, known to NATO as the SA-2 guideline, fundamentally shattered the high-altitude doctrine. When Francis Gary Powers had his U-2 spy plane shot down over the Soviet Union in 1960 by an SA-2, the Air Force realized that altitude was no longer a sanctuary. If a U-2 cruising at 70,000 feet could be swatted out of the sky, a B-52 at 50,000 feet was a sitting duck. How does a strategic bomber force adapt when its primary defensive mechanism is rendered obsolete overnight? The answer was a radical shift to low-level penetration. SAC retrained its crews to fly these massive 8-engine bombers just a few hundred feet off the deck, utilizing the terrain to mask their approach from Soviet early warning radars. This put immense structural stress on the airframes, forcing Boeing to implement extensive structural modification programs to strengthen the wings and fuselage. The B-52 was never designed to be a low-altitude, terrain-following bomber, yet American engineering ingenuity and crew skill forced it into that role. The internal layout of the B-52 was a stark departure from the bombers of the past. It required a highly specialized crew of 6. On the upper deck, you had the aircraft commander and the pilot sitting side by side, wrestling with heavy flight controls that relied on a complex system of cables and pulleys rather than modern fly-by-wire systems. Behind them sat the electronic warfare officer and the gunner in later models. On the lower deck, working in windowless isolation, were the radar navigator and the navigator, responsible for guiding the aircraft across featureless oceans and Arctic ice caps to precise release points. In the early variants, from the A model through the F model, the tail gunner sat in a pressurized compartment at the extreme rear of the aircraft. This was perhaps the most terrifying and lonely position in the entire United States military. Connected to the rest of the crew only by an intercom, the tail gunner was tasked with defending the rear hemisphere of the bomber using a quad mount of 50 caliber machine guns. In the event of a catastrophic failure or a bailout order, the tail gunner had to manually jettison the turret and physically jump from the aircraft, while the rest of the crew utilized downward and upward firing ejection seats. Logistically, keeping a fleet of over 700 B-52s operational was a monumental task that tested the limits of the American military supply chain. These aircraft consumed aviation fuel at an astonishing rate. A B-52 has a fuel capacity of over 47,000 gallons, distributed across multiple tanks in the fuselage and the wings. To fulfill its intercontinental mission, the B-52 relied heavily on aerial refueling. This necessity birthed the Boeing KC-135 Stratotanker, an aircraft developed in parallel with the B-52 to ensure that SAC bombers could reach any target on the globe. The coordination required to launch a fleet of bombers from bases in North Dakota or Maine, rendezvous with a fleet of tankers over the Arctic Circle in total radio silence, and proceed to targets in the Soviet Union was a masterpiece of logistical planning. During the height of the Cold War, under operations like Chrome Dome, the Air Force kept a portion of its B-52 fleet airborne 24 hours a day, fully armed with thermonuclear weapons. This airborne alert posture ensured that even if a Soviet first strike obliterated American air bases and missile silos, a devastating retaliatory blow was already in the air and moving toward its targets. But a weapon system designed for the apocalypse soon found itself thrust into a very different kind of conflict. The pristine, high-tech vision of a nuclear exchange over the Arctic was about to be replaced by the sweltering, muddy reality of a conventional ground war in Southeast Asia. The strategic planners in Washington realized that their multi-million-dollar nuclear deterrent was going to have to adapt to a tactical environment it was never intended to operate in. The massive bomb bays, designed to hold a few large thermonuclear gravity bombs, would have to be heavily modified to carry dozens of conventional iron bombs. The pristine silver paint jobs would be replaced by jungle camouflage. The B-52 was about to transition from a theoretical instrument of global annihilation into a terrifyingly practical tool for close air support and interdiction. The stage was set for a doctrinal collision, where the ultimate weapon of the Cold War would be unleashed against a determined, decentralized enemy hidden beneath a dense jungle canopy. The transformation of the B-52 from a high-altitude nuclear delivery platform into a tactical carpet bomber required a massive engineering overhaul, culminating in a program bluntly named Big Belly. The early B-52F models deployed to the Pacific simply did not have the internal volume to carry enough conventional ordnance to justify their massive operational costs. Boeing engineers went back to the drawing board to radically modify the internal bomb bays of the B-52D variant. By rearranging the internal structures and installing high-density bomb racks, they increased the internal capacity from 27 weapons to a staggering 84 500-pound Mark 82 general-purpose bombs. But they did not stop there. The external pylons under the massive swept wings were reinforced to carry an additional 24 750-pound M117 bombs. A single B-52D could now carry 108 bombs, totaling roughly 60,000 pounds of high explosives per mission. To camouflage these massive aircraft during night operations, the Air Force painted the bellies and lower fuselages a glossy jet black, a stark contrast to the standard Southeast Asia camouflage pattern applied to the upper surfaces. When a three-ship formation of these modified B-52s, known as a cell, arrived over a target, the results were apocalyptic. This was not precision bombing in the modern sense. This was area saturation. A single three-ship cell would drop their payloads in a precisely calculated pattern, creating a footprint of destruction known as a B-52 box. This box was typically 1 mile wide and 2 miles long. Inside that grid square, over 300 high-explosive bombs would detonate within seconds of each other. The overpressure from the overlapping blast waves would instantly vaporize foliage, shatter concrete bunkers, and turn the jungle floor into a lunar landscape of overlapping craters. How do you defend against an enemy you cannot see, hear, or reach? The brutal reality for the enemy forces on the ground was that they simply could not. Because the B-52s flew at altitudes exceeding 30,000 feet, they were completely invisible and inaudible from the jungle floor. The first indication of an attack was not the roar of jet engines, but the sudden, catastrophic eruption of the Earth itself. Survivors described the experience as being caught in a localized earthquake, where the shock waves ruptured eardrums, collapsed lungs, and induced a state of psychological trauma that paralyzed entire battalions. This level of devastation draws a direct historical parallel to the rolling artillery barrages of the First World War at the Somme or Verdun. In those conflicts, hundreds of artillery pieces fired for days to saturate a trench line. The B-52 achieved the same level of geographical obliteration in less than 30 seconds. However, unlike the static artillery parks of 1916, the B-52s were projecting this firepower from bases thousands of miles away. The logistical tail required to sustain Operation Arclight, the codename for the B-52 bombing campaign in Southeast Asia, was staggering. The primary staging ground was Andersen Air Force Base on the tiny island of Guam in the Marianas. Andersen was located over 2,500 miles from the target zones in Vietnam. To execute a single mission, a B-52 crew faced a grueling 12 to 14-hour round trip. Let us break down the brutal mechanics of an Arclight mission. Ground crews on Guam worked in suffocating 100-degree tropical heat and saturated humidity, manually winching thousands of iron bombs into the bellies of the aircraft. The tarmac at Anderson was a massive, sprawling industrial complex of munitions dumps and fuel farms. When a cell of bombers took off, the heavily laden aircraft required almost every inch of the 2.5-mile runway to get airborne, their 8 J-57 engines screaming at maximum thrust, trailing thick black smoke. Because of the immense fuel burn required to lift 60,000 pounds of bombs, the B-52s had to rendezvous with KC-135 Stratotankers over the South China Sea for mid-air refueling. Connecting a massive bomber to a flying gas station via a rigid boom while flying at 300 miles per hour through turbulent monsoon weather required immense physical strength and precision from the pilots. Once refueled, the bombers pushed toward the mainland, transferring control from their onboard navigators to ground-based radar stations. Using a system called Combat Sky Spot, ground controllers in South Vietnam tracked the bombers on radar and calculated the exact release point based on wind speed, altitude, and trajectory, radioing a countdown to the bomber crews. When the bombardier hit the release toggle, the aircraft would violently lurch upward, suddenly freed from 30 tons of dead weight as the lethal payload began its long fall to the earth. The ultimate test of this tactical bombing doctrine occurred in the early months of 1968 during the siege of Sanh. Deep in the mountainous terrain near the Laotian border, roughly 6,000 United States Marines were surrounded and heavily besieged by an estimated 20,000 to 30,000 troops of the North Vietnamese Army. General William Westmoreland initiated Operation Niagara, a massive application of airpower designed to break the siege. The situation at Sanh bore a striking resemblance to the Battle of Bastogne in 1944, where the surrounded 101st Airborne Division was saved by a break in the weather that allowed Allied fighter bombers to pound the encircling German armor. But at Sanh, the scale of air support was magnified exponentially by the B-52. The battlefield at Sanh was a nightmare of fog, monsoon rain, and relentless incoming artillery fire. The Marines were dug into muddy trenches, enduring a daily pounding. To relieve the pressure, the Air Force utilized B-52s for close air support, a role they were never originally intended to perform. Ground controllers began walking the B-52 strikes closer and closer to the Marine perimeter. Initially restricted to targets 3,000 yards away, the sheer desperation of the siege forced commanders to shrink the safety margin. Eventually, B-52s were dropping 30-ton payloads within 1,000 yards of American lines. The tactical precision required was absolute. A navigational error of a fraction of a degree or a release delay of a single second would have resulted in hundreds of American casualties from friendly fire. The B-52 strikes were relentless, arriving every 90 minutes, 24 hours a day. The earth shook so violently that Marines in their bunkers reported being bounced inches off the ground with every wave. The massive carpet bombing utterly pulverized the North Vietnamese trench lines, destroyed their supply caches, and broke the back of their siege operations.
Over the course of the battle, B-52s dropped over 75,000 tons of bombs around Sanh. It was a brutal, uncompromising display of industrial annihilation that proved the strategic bomber could dictate the outcome of a tactical ground battle. However, the unchallenged supremacy the B-52 enjoyed over the jungles of South Vietnam was violently shattered when the strategic focus shifted north. In December 1972, President Richard Nixon ordered Operation Linebacker II, a maximum-effort bombing campaign directed against the heavily defended heartland of North Vietnam, specifically the capital city of Hanoi and the port of Haiphong. This was no longer a tactical support mission against guerrilla forces in the jungle. This was a direct assault on one of the most sophisticated, densely integrated air defense networks on the planet. The Soviet Union had supplied North Vietnam with massive quantities of the S-75 Davina surface-to-air missile, the infamous SA-2 guideline. The SA-2 was a 35-foot-long flying telephone pole, traveling at Mach 3.5, carrying a 430-pound fragmentation warhead designed to shred heavy bombers. Why would the greatest air armada in history fly predictable, straight-line approaches into the teeth of the deadliest air defense network on Earth? The answer lies in the rigid, uncompromising doctrine of the Strategic Air Command. When Linebacker 2 began on the night of December 18th, the B-52s were ordered to fly in massive formations, utilizing the exact same altitudes, approach routes, and airspeeds. Even worse, SAC headquarters in Omaha, Nebraska, mandated a specific maneuver called a post-target turn. Immediately after dropping their bombs, the massive aircraft were ordered to execute a steep banking turn to exit the target area. This maneuver turned the bombers directly into the high-altitude jet stream, drastically reducing their ground speed and making them nearly stationary targets on enemy radar screens. Furthermore, the banking maneuver disrupted the bombers' electronic jamming signals, momentarily exposing them to the tracking radars of the SA-2 batteries. The results of this tactical rigidity were catastrophic. Over the first 3 nights of the operation, the skies over Hanoi were illuminated by the terrifying glare of hundreds of SA-2 missiles rocketing upward. The Soviet-trained missile operators quickly identified the predictable flight paths and the vulnerability of the post-target turn. They began firing missiles in salvos, creating a wall of flying shrapnel. B-52s were ripped apart in the night sky, their massive wings sheared off by the proximity fuses of the SA-2s. The radio frequencies were filled with the frantic calls of crews bailing out of burning aircraft. The Air Force lost 11 B-52s in just 3 days. The invincible flying fortress was taking unacceptable losses, and crew morale was plummeting. The rigid Cold War doctrine that looked perfect on a chalkboard in Nebraska was getting American aviators slaughtered in the flak-filled skies over Hanoi. Faced with a potential mutiny and the failure of the campaign, commanders on the ground, including General John C. LeMay, forced a radical change in tactics. They threw out the SAC playbook. On the 8th night of the campaign, the Air Force launched a massive, coordinated strike of 120 B-52s. But this time, they did not fly in a single predictable line. They approached Hanoi from multiple directions simultaneously, varying their altitudes and utilizing unpredictable evasive maneuvers. They completely abandoned the fatal post-target turn, opting instead to fly straight through the target area and exit rapidly. The electronic warfare officers maximized their jamming capabilities, creating a chaotic wall of static on the enemy radar scopes. The tactical shift was a masterclass in adaptability. The massive armada overwhelmed the North Vietnamese air defenses. The SA-2 batteries fired blindly into the jamming interference, exhausting their missile stockpiles. Over the course of 11 days, the B-52s dropped over 15,000 tons of ordnance on Hanoi and Haiphong, obliterating rail yards, power plants, and petroleum reserves. The sheer scale of the destruction forced the North Vietnamese back to the negotiating table in Paris. But the victory came at a heavy price. 15 B-52s had been shot down, and over 30 airmen were killed or captured. The Operation Linebacker 2 campaign proved that the Stratofortress could survive in a modern, dense surface-to-air missile environment, but only if commanders were willing to adapt their tactics to the brutal realities of the battlefield. The massive aircraft had proven its lethality with conventional iron bombs, but the era of unguided carpet bombing was slowly drawing to a close. As the smoke cleared over Southeast Asia, the military-industrial complex was already developing new technologies that would fundamentally alter the way the United States waged war. The question now was how this aging, 8-engine behemoth of the Cold War would adapt to an upcoming era defined by microchips, laser guidance, and stealth. The realization that a massive 8-engine bomber with the radar cross-section of a barn could no longer penetrate advanced Soviet airspace without suffering catastrophic losses forced a fundamental evolution in American strategic doctrine. How does a lumbering giant survive in an era dominated by advanced surface-to-air missiles and supersonic interceptors? The answer was to stop flying over the target and start shooting from the front porch. The 1980s saw the B-52 undergo a radical transformation from a gravity bomber into a standoff missile carrier. Boeing and the Air Force integrated the AGM-86 air-launched cruise missile, a weapon that fundamentally altered the geometry of the Cold War. A single B-52H could now carry 20 of these nuclear-tipped cruise missiles, 8 on a rotary launcher inside the bomb bay and 12 on external pylons. The bomber no longer needed to brave the lethal terminal defenses of Moscow or Leningrad. Instead, a B-52 could launch its payload from hundreds of miles away, over the safety of the Arctic Ocean or the North Sea, unleashing a swarm of low-flying, terrain-following missiles that would slip beneath Soviet radar screens. This technological leap extended the relevance of the Stratofortress by decades, turning it into a flying missile silo that could strike with pinpoint accuracy while remaining comfortably outside the threat ring of enemy air defenses. This standoff capability was spectacularly validated in the opening hours of Operation Desert Storm in January 1991, during a highly classified mission known as Operation Secret Squirrel. While the world watched stealth fighters and Tomahawk missiles strike Baghdad on CNN, the longest combat mission in aviation history up to that point was already underway. 7 B-52G models lifted off from the freezing runway at Barksdale Air Force Base in Louisiana. They flew continuously for 35 hours, covering over 14,000 miles round trip, requiring multiple mid-air refuelings over the Atlantic and the Mediterranean. Their payload was not nuclear, but a newly developed conventional variant of the cruise missile, the AGM-86C. Arriving in the airspace over the Middle East, these 7 bombers unleashed 35 conventional cruise missiles, devastating Iraqi communication nodes and power grids with absolute surprise. The sheer logistical audacity of launching a strike from the American homeland, hitting targets in the Middle East, and returning to Louisiana without ever landing is a testament to the unparalleled global reach of the United States Air Force. When the air campaign of Desert Storm shifted to targeting the entrenched Iraqi army, the B-52 reverted to its terrifying role as a conventional carpet bomber, but with a psychological twist. The Iraqi Republican Guard was heavily fortified in the desert, dug into deep trench networks reminiscent of the First World War. The Air Force initiated a campaign of psychological warfare, dropping leaflets that explicitly warned Iraqi units that they would be bombed by B-52s the following day.
True to their word, cells of B-52s would arrive from high altitude, completely unseen, and unleash thousands of tons of Mark 82 unguided bombs. The physical devastation was absolute, but the psychological impact was even more profound. This strategy draws a direct historical parallel to General William Tecumseh Sherman's march to the sea during the American Civil War. Sherman's objective was not merely to destroy the Confederate Army, but to obliterate the infrastructure and the psychological will of the South to continue fighting. Similarly, the B-52 strikes in the desert were designed to break the minds of the Iraqi defenders. Entire battalions of Iraqi soldiers, deafened and traumatized by the relentless, earth-shattering bombardments, surrendered to the first coalition ground forces they saw, often abandoning fully functional tanks and artillery pieces. The bomber had proven that overwhelming, indiscriminate firepower could paralyze an enemy army before a ground offensive even began. Yet, the nature of warfare was shifting rapidly toward precision, and the B-52, a relic of the analog age, had to adapt or face the scrapyard. The integration of the MIL-STD-1553 digital data bus allowed this mid-century airframe to communicate with 21st-century smart weapons. The addition of the Lightning targeting pod, mounted on an external pylon, gave the B-52 crew the ability to laze their own targets and drop laser-guided bombs. But the true revolution came with the Joint Direct Attack Munition, or JDAM. By strapping a GPS guidance tail kit onto a standard dumb bomb, the B-52 became a precision sniper rifle. What happens when a strategic bomber designed to level cities is tasked with supporting a four-man special forces team on a remote mountaintop? You get the surreal tactical environment of Operation Enduring Freedom in Afghanistan in 2001. During the Battle of Tora Bora and the wider campaign in the Hindu Kush, B-52s would launch from the island of Diego Garcia in the Indian Ocean and loiter at 39,000 feet over Afghanistan for hours. Down below, American Special Forces operators, sometimes riding on horseback alongside the Northern Alliance, would spot Taliban or Al-Qaeda positions. Using handheld GPS devices and laser rangefinders, they would transmit the coordinates directly to the B-52, orbiting miles above. Within minutes, a 2,000-pound JDAM would fall from the sky, striking a cave entrance or a bunker with a margin of error measured in feet. This integration of 19th-century cavalry mobility with 21st-century aerospace engineering is staggering. It is highly reminiscent of the close air support provided by P-47 Thunderbolts over the hedgerows of Normandy in 1944, where fighter bombers waited for ground controllers to call in strikes on German armor. But instead of a single pilot visually diving on a target with a 500-pound bomb, the B-52 provided a continuous, on-call arsenal of precision destruction that could obliterate an entire ridgeline over the course of a single loiter period. To maintain this relentless operational tempo, the logistics and engineering required to keep a fleet of aircraft built in the early 1960s flying well into the 21st century border on the miraculous. The United States Air Force currently operates a fleet of 76 B-52H models, the last of which rolled off the Boeing assembly line in Wichita in 1962. The secret to their longevity lies in their massive, over-engineered structural design. Unlike modern, highly stressed fighter jets that consume their airframe fatigue life in a few thousand hours, the B-52 was built like a flying bridge, capable of absorbing immense punishment and structural loading. However, parts break, and the original supply chains dried up decades ago.
When a B-52 needs a critical structural component that is no longer manufactured, the Air Force turns to the 309th Aerospace Maintenance and Regeneration Group, better known as the Boneyard, at Davis-Monthan Air Force Base in the scorching heat of the Arizona desert. The Boneyard is not merely a graveyard. It is a massive open-air parts repository. In recent years, the Air Force has even resurrected entire B-52s from the Boneyard to replace aircraft lost in accidents. The painstaking process of bringing an aircraft like the one nicknamed Ghost Rider out of deep storage, replacing its dried-out seals, updating its avionics, and flying it back into active service is a testament to American maintenance crews. The B-52 is the aviation equivalent of the John Browning M250 caliber machine gun. You do not discard a weapon system that perfectly fulfills its physical requirements. You simply upgrade the optics, the ammunition, and the internal mechanisms. The fundamental platform remains unmatched. Economically, the B-52 represents an unparalleled return on investment for the Department of Defense. While stealth bombers like the B-2 Spirit cost over $2 billion each and require climate-controlled hangars and specialized maintenance for their radar-absorbent coatings, the B-52 can sit on a sun-baked tarmac in Guam or a freezing flight line in North Dakota and be ready to fly in hours. Its cost per flight hour is a fraction of its stealthy counterparts. In a permissive airspace environment where enemy air defenses have been degraded, there is simply no need to risk a multi-billion-dollar stealth asset when a 70-year-old B-52 can deliver a vastly larger payload for pennies on the dollar. It acts as the ultimate bomb truck, providing unmatched volume and persistence. To ensure this economic and tactical dominance continues, the Air Force is currently executing the most significant upgrade in the history of the airframe, the Commercial Engine Replacement Program. The original Pratt & Whitney TF-33 turbofans, which have powered the H models since the 1960s, are finally being retired. They are being replaced by 8 modern Rolls-Royce F130 engines. These new power plants will provide greater fuel efficiency, increased range, and significantly reduced maintenance requirements, eliminating the need to tear down engines every few hundred flight hours. Coupled with a massive upgrade to the aircraft's radar system, replacing the legacy mechanical scanners with an active electronically scanned array radar adapted from the F/A-18 Super Hornet, the B-52 is being transformed into a digital warship. These upgraded aircraft, which will likely be redesignated as the B-52J, are slated to remain in active service until the 2050s. Beyond the tactical and economic realities, the B-52 serves as a highly visible instrument of geopolitical maneuvering. In the realm of international relations, stealth is a liability when you want your enemy to know exactly where you are. When the United States wants to send an unambiguous message of deterrence to a peer adversary, it does not send a B-2 bomber that cannot be seen on radar. It sends a bomber task force of B-52s. When a pair of Stratofortresses flies a long-duration mission from Minot Air Force Base over the North Pole, skirts the edges of Russian airspace, or conducts a low-level flyby over an Allied aircraft carrier in the South China Sea, it generates a massive, undeniable radar signature. That is not a vulnerability. That is the entire point. The B-52 acts as a flying billboard of American resolve, a physical manifestation of the nuclear triad
and conventional strike capability. It reassures allies and forces adversaries to recalibrate their strategic calculus, knowing that a single aircraft loitering off their coast carries enough firepower to cripple their military infrastructure. The story of the B-52 Stratofortress is not just a chronicle of cold metal, jet fuel, and high explosives. It is a narrative of relentless American industrial adaptation and the generations of airmen who have manned its cramped, freezing crew compartments. We have reached a point in history where a pilot flying a B-52 today might be sitting in the exact same seat, looking at the exact same analog dials as their father and their grandfather did before them. It is a machine born from the existential dread of the early Cold War, baptized in the dense jungles of Southeast Asia and refined in the deserts of the Middle East. It has outlived the Soviet Union. It has outlived the engineers who drafted its original blueprints in a Dayton hotel room. And it has outlived every aircraft designed to replace it. The true measure of a weapon system is not found in its aesthetic beauty or its theoretical capabilities, but in its brutal, uncompromising ability to adapt to the shifting demands of the battlefield and impose its will upon the enemy. The Boeing B-52 has done exactly that for over 70 years, standing as the undisputed titan of the skies, a testament to the terrifying calculus of strategic air power. Which attribute of the B-52 do you believe is most responsible for its unprecedented longevity in the United States Air Force? A. Its massive structural design that allows for endless payload and avionics upgrades. B. The shift to standoff cruise missiles, keeping it out of the range of modern air defenses. C. Its unmatched cost-effectiveness and logistical reliability compared to modern stealth bombers. Drop your answer in the comments below and let the tactical debate begin.